Hello students, week 15 physics for grade 12, chapter 40, lesson number 7, nuclear fusion, textbook page 821 and 822. At the end of the lesson, you will be able to compare the total mass of the products of fusion to the mass of the nuclei that fused. The steepest part of the energy hill is from hydrogen to iron. Energy is released as light nuclei fuse or combine rather than split apart. This process is nuclear fusion. In the last lesson, you learned nuclear fission, splitting of a heavy nucleus into two or more small nuclei. Here, this is opposite. Nuclear fusion is combining, or you can say fusing, two lighter nuclei into a heavy nucleus. Energy is released when heavy nuclei split apart in the fission process. In nuclear fusion, energy is released when light nuclei fuse together. So a proton has more mass by itself than it does inside a helium nucleus. The mass of a single proton is more than the mass per nucleon in a helium-4 nucleus. So what does it mean? If a proton is single, it has more mass than the proton when it is inside the nucleus. You have to say mass per nucleon in a helium-4 nucleus. You can see the figure here. Proton has more mass by itself, you can see at the top, and then than inside a helium nucleus. So there you can see proton inside the nucleus. There are two protons inside the helium nucleus. This has more mass than the proton that is alone. Two protons and two neutrons have more total mass when they are free than when they are combined in a helium nucleus. So for the particles they are free, the mass is actually greater than when they are together in a nucleus. Atomic nuclei are positively charged. For fusion to occur, they must collide at very high speeds to overcome electrical repulsion. Fusion brought about by high temperatures is called thermonuclear fusion. In the central part of the Sun, about 657 million tons of hydrogen are converted into 653 million tons of helium each second. See, the missing 4 million tons of mass is discharged as radiant energy. So, in each second, nuclear fusion occurs in the central part of the Sun. In both chemical and nuclear burning, a high temperature starts the reaction. If you compare chemical and nuclear reactions, a high temperature starts the reaction. The release of energy by the reaction maintains a high enough temperature to spread the reaction. The result of the chemical reaction is a combination of atoms into more tightly bound molecules. In nuclear reactions, the result is more tightly bound nuclei. So the difference between chemical and nuclear burning is essentially one of scale. So there is no big difference except the requirement of high temperature in case of nuclear fusion. Think question there. First, it was stated that nuclear energy is released when atoms split apart. Now, it is stated that nuclear energy is released when atoms combine. Is this a contradiction? What do you think? Okay, look at the answer. This is contradictory only if the same element is said to release energy by both the processes of fission and fusion. Only the fusion of light elements and the fission of heavy elements result in a decrease in nucleon mass and a release of energy.